The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, so on your screen, can you see Webassign on the left side of the screen?
Yes.
Okay, great. Just want to make sure I push the right buttons. Okay, so today we're going to take a look at section 3.7, which is graphing linear inequalities. And let me get down to a blank spot here. Let's say we have the equation x. Apparently it doesn't want to let me. Let's try this again. Here we go. X plus y equals 5. Okay. Now this is a linear equation. And to graph this thing, let's find the x and y intercepts. We don't have to use the intercepts, but I'm just going to go ahead and do that anyway. So to find the x-intercept, I'll set y equal to 0. To find the y-intercept, I'll set x equal to 0. If y is 0, we get x plus 0 equals 5. Therefore, x equals 5. So the x-intercept is at 5, 0. To find the y-intercept, we set x equal to 0, and we get x, 0 plus y equals 5. That is to say, y equals 5. So the y-intercept is at 0, 5. Now, if I want to plot this equation on the Webassign graph, I click on the line. Again, I don't choose the ray or the line segment. I choose the line, click on it till it turns blue. Then I come over here to the graph, and I'm going to graph 5, 0 and 0, 5. And there is my line. I can come over here and make sure that I have the correct ordered pairs. So everything looks good. Any questions about that? All right. Now, instead, we're going to take a look at, come back here, x plus y is greater than or equal to 5. Well, we already know what what equal to 5 looks like, right? This graph over here is x plus y is equal to 5. But now we not only have the line, but we have everything on one side or the other side of the line. What we have here is this plane, the XY coordinate system, rectangular coordinate system. We've cut through it with a line. Now we're going to pick which side of this is x plus y greater than 5. We already know what equal to 5 is, but what about greater than? Okay. So what we're going to do is we're going to pick a test point. It has to be a point that is not on this line. It's either up here or down here. 0, 0 is a nice, easy point to pick, and it's not on the line. So I've got a test point of 0, 0. So I'm going to plug that into my inequality and see what I get. 0 plus 0 greater than or equal to 5. 0 greater than or equal to 5. That is a false statement, right? So the test point fails. What that tells me is that I am not going to shade below the line the area that contains 0, 0. Therefore, I'm going to shade above the line. Just to confirm that, I don't have to do this, but I'm going to choose an additional test point. How about 5, 5? This one should work because our solution is either on this side of the line or on that side of the line, including the line. All right, 5, 5 would give us 5 plus 5 greater than or equal to 5, 10 greater than or equal to 5. That's true. So that means that over here above, the area containing the point 5, 5 is the solution. Now, I don't want to click on that. What I want to do is this. I want to fill this side. So I've now shaded above the line. So my solution for this linear inequality, x plus y greater than or equal to 5, includes the solid line and everything above the line. Any questions about this example? All right. And this is the main thing we're doing today. So don't panic if you're like, well, I'm not quite sure. We're going to keep looking at examples of this. I'm going to come back over here and I'm going to change my inequality statement. And what I'm going to do, let's see, first of all, I want to erase just that. Okay. And come back here. Now, let's say that this is what I was going to graph, x plus y greater than 5, all right? I would still consider the equals to get my points for the line, okay? And I would graph, let's see, let's go back here and let's clear all of this. And so now I would still graph the point 5, 0, and 0, 5, which would give me a line, except that, again, this is what I'm actually graphing. It does not include the equals. So this line needs to establish the boundary between the two sides, but it's not included. So what I do here is I make it a dashed line, okay? That's kind of like a parentheses or an open circle on a number line. It says, here's the fence line, okay? Like this is my property, this is the neighbor's property, here's the fence line, but I don't own the fence. It establishes where my property stops, but it's not my fence. Now, using the same test points, I conclude that I want to fill this side of the line, okay? So x plus y greater than 5 looks just like the previous example, but the line is not solid, it's dotted. When is it solid? When the problem we're looking at includes equals to. When is it dashed or dotted? When it doesn't include equal to. Okay, any questions about this example? Okay, we're going to start all over. And give me a second here. Let's see. This says graph each inequality. And I have 5x plus 4y greater than or equal to 20. Now, what I'm going to do next is just consider the equation 5x plus 4y equals 20 to establish where the line is, whether it's dashed or solid, but I need to establish where it is. Again, I can choose other points, but I'm going to go ahead and use x and y intercepts. So again, I'm dealing with this equation. If y is 0, I get 5x plus 4 times 0 equals 20. 5x plus 0 equals 20. 5x equals 20. Dividing both sides by 5, I get x equals 4. So the x-intercept is at 4, 0. Now let's go back and find the y-intercept. To set x equal to 0, let's see, we get 5 times 0 plus 4y equals 20. 5 times 0 is 0. 0 plus 4y equals 20. 0 plus 4y is 4y. 4y equals 20. Divide both sides by 4. Y equals 5. Okay, so now I have 2 points to establish the line. So let's see, 4, 0, and 0, 5. I'm going to confirm, yes, my points are where I need them. Now, my next question is, Should this line be solid or dashed?
Solid.
Yes, because I'm actually doing this graph and it includes the equal. Okay, so I want this line to be solid. Excellent. So now from here on out, we're actually going to consider the inequality, and I'm going to pick a test point. Again, 0, 0 is not on the line, so that looks like a good test point. So I'm going to use 0, 0, and that's going to go in here. 5 times 0 plus 4 times 0 greater than or equal to 20. 0 plus 0 greater than or equal to 20. 0 greater than or equal to 20. That is false. So the test point, 0, 0, fails, which means my solution is on the other side of the solid line. So fill, there it is, and there's my solution. Again, if I pick a test point and it works, I choose that side. If it fails, I choose the other side. If you're not real confident in your choices, you could then pick a point over here and verify that, yes, it does work. Anyway, so there's the final answer. And again, I've got a solid line. It's in the correct location, and I've shaded the correct side of the line. Any questions? All right, let's take a look at another example. And this is 3x minus 2y is greater than 6. So I'm going to consider the equation 3x minus 2y equals 6 to find where I would plot that line. Okay, again, I'm using the intercepts. If y is 0, 3x minus 2 times 0 equals 6. 3x minus 0 equals 6. 3x equals 6. And you can go straight down to here. You don't have to write each little step. I'm just writing them in case somebody's getting lost. X is 2. Okay. Now, if x is 0, we get 3 times 0 minus 2y equals 6. 0 minus 2y equals 6. Negative 2y equals 6. Y equals negative 3. Okay. So now I come over to my graph. I get the line 2, 0, 0, negative 3. Only because the actual thing I'm graphing does not include the equal sign, I need to make this into a dashed line. Okay. Now let's pick a test point. I'm going to go with 0 again. 0, 0, that is. So test point. 0, 0. And I'm going to plug that in over here. 3 times 0 minus 2 times 0 greater than 6. 0 minus 0 greater than 6. 0 greater than 6. False. So that means 0, 0 is not part of the solution. Therefore, the solution is over here. So I will fill that side. And there is the correct solution. Again, my line is dashed because it does not include equals to, and I shade the side where I could find a test point that works. Since a test point over here failed, I automatically know it's on the other side of the line. Any questions there? All righty. Let's see here. Clear this and go to another inequality. Let's see here. How about this one? Y greater than or equal to negative 2x plus 5. So again, I'm going to look at the equation y equals negative 2x plus 5. All right. I'm going to find two ordered pairs. If y is 0, I get 0 equals negative 2x plus 5. I'll add 2x to both sides of the equation. 2x equals 5. Divide both sides by 2. X is 5 halves. Okay. Next, if x is 0, y equals -2 times 0 plus 5. Y equals 0 plus 5. Y equals 5. Okay. So I've got my 2 points. Let's see. 5 halves is 2.5. So 2.5, 0. And then 0, 5. Now, notice it moved. It didn't go where I wanted it to. No need to panic. I come over here. I need this to be 5 halves. Now, again, don't use mixed numbers and don't round off fractions. Okay. Make them exact. So 5 halves, comma 0, 0, 5. Okay. So now my line is where I need it to be. Should it be a solid line or just a dashed line?
Solid.
Excellent. Okay. So now let's pick a test point. Tell you what, let's pick something besides 0, 0. How about let's pick 8, 1. 8, 1. Okay. If x is 8 and y is 1, we get 1 greater than or equal to -2 times 8 plus 5. 1 greater than or equal to -16 plus 5. 1 greater than or equal to -11. Is 1 greater than or equal to -11? It is greater than. So this is true. So 8, 1, that point right there is part of the solution. Now be careful. There's a temptation to put your, to go and do, let's see here. Oh, good, it won't let me. Anyway, you don't want to click on a point there. You want to fill it on that side. Okay. Any questions on that problem? All righty. Let's see here. Clear that and do another example. See how we doing for time. Lots of time. Y is less than 3x. Okay. So once again, I want to look at the equation. I'm going to look at y equals 3x. And I'll go ahead and use the x and y intercepts. If y is 0, 0 equals 3x. Divide both sides by 3, x equals 0. Oh, this goes through the origin, doesn't it? So I'm going to have to pick something different than let x equal 0 because I'll just get 0, 0 again. How about letting x equal 1? So then y equals 3 times 1. Y equals 3. Okay. So now I've got my 2 points. Come over here and 0, 0, 1, 3. Let's verify that it says, yep, it's where I want it to be. Okay, solid line or dashed?
Dashed.
Correct. This down here is only to establish where the line would be. Because it does not include equals, it's going to be a dashed line. All right. Also, I can't use 0, 0 as a test point here because that's on that dotted line. Okay. So let's pick something else. Oh, how about 3, 3? Okay, 3, 3. And again, I don't have a specific reason for choosing 3, 3. I'm just picking some point, not on the line. I'm going to plug that in there. 3 less than 3 times 3. 3 less than 9. That's true. So 3, 3 is on the correct side, so we'll fill that side. And there's the solution. Any questions there? Okay. New problem. How about this? Y greater than -3. Oh, we have just one variable. Well, let's consider the equation y equals -3. Now this goes back to those 10 items that I listed the other day, one of which says y equals a constant is a horizontal line. Okay, so I need a couple of points. Let's see, y is -3 no matter what. How about if x is 0 and x is 1? Okay, so x is 0, y is -3, x is 1, y is -3. And again, we have a horizontal line. But should it be solid or dashed? Solid or dashed? Dashed, correct. Okay, because it does not include the equal to. Remember, this is just to get where the points are. This is what we're actually graphing. Oh, and we certainly could pick a test point of 0, 0. There's a test point. We plug that in, we get 0 greater than -3. Is that true? Yes. So 0, 0 is a correct solution. So we're going to fill above the line. And there you have it. Okay. Another way we could look at this, let's go back and let's not do the fill yet. This says y is greater than -3. Well, this dashed line is y equals -3. So where would greater than that be? Up above here. Okay. But again, nothing wrong with using the test point method. Any questions there? Okay, let's take a look at another one. This says x minus 1.5 less than or equal to 0. Well, if an equation or an inequality just has one variable, we should solve for that variable first. So we're going to add 1.5 to both sides of the equation. So the inequality, the equation would be x equals 1.5. Oh, but that's a vertical line, isn't it? It's a vertical line where all the x's are 1.5 and the y's can be whatever they want to be. So got our line 1.5 comma 0 and 1.5 comma 1. Again, notice it doesn't graph it where I want it to. I've got to come in here. Now, I can use a decimal as long as it's exact. Okay. For instance, if it was 2/3 and I put 0.6, that is incorrect. It would have to be 0.6 repeating, which is tricky to do in Webassign. So we would just keep it with 2/3. Okay. So is the line supposed to be solid or dashed?
Solid.
Solid. Excellent. Okay. It says x is less than or equal to 1.5. So do you think it's going to be over here or over there, where x is less than or equal to 1.5? Here or there?
To the right?
That would be to the right, though. That would be greater values than 1.5. It says x is less than or equal to.
Oh, to the left.
Yeah. Do you see why?
Because it's less.
Yeah. Okay. Let's take a test point 0, 0. Just to make sure. Plug it in. Let's see. Yeah, we'll plug it in there. So we get what? 0 minus 1.5 less than or equal to 0, negative 1.5 less than or equal to 0. That's true. So hang on a second here. Yeah. So that would be over here. Okay, because 0, 0 is right there. All right, good to go on that. Okay, what I'm going to do now, I'm going to change the screen for a minute and go back in here where you can't see, and give me just a minute here. I had a request from a student, and it was actually from this coming up assignment. So we're going to go ahead and look at it. Just a minute. Okay, so now it says graph the inequality, and let's see what's incorrect about it. Let's see if this is the one I thought it was. Yes. Okay. Nah, we'll get to that. All right. So we've got 9x plus y greater than or equal to -4. Okay. So first of all, I'm going to consider the equation 9x plus y equals -4. And what I'm going to do, I'm going to go ahead and use the same ordered pairs. It looks like they use the x and y intercepts. So we'll do that. Okay. So if y is 0, we get 9x equals -4. Divide both sides by 9, x equals -4 ninths. Okay. If x is 0, we get 9 times 0 plus y equals -4, y equals -4. So our 2 points should be -4 ninths 0 and 0 -4. Now, I don't know if you can see this very well, but can you see that their point, they've got 0 -4, which corresponds to this? Can you read that on your screen?
Yes.
Okay, but look down here what they wrote. For -4 ninths, they wrote -0.444. Well, if on your calculator you put in -4 divided by 9, you do get -0.44 on and on repeating. But because they stopped at 3 digits, they technically rounded off. So that point is not correct. So that's the first problem. That needs to be left as the fraction -4 ninths. Okay. Now, let's pick a test point. And let's go ahead and use 0, 0. Okay. I've deliberately skipped something that we'll come back here to in a minute. It's greater than or equal to -4. Is that correct? Yes, that's true, right? So we would shade on the right side. So that's correct. But there's one other thing that's incorrect about this graph. What is it?
Dash.
Right, it should be a solid line, not a dashed line. So 2 things wrong with the problem. 1, don't round off a fraction. 2, pay close attention to whether it's a dashed line or a solid line. Okay. Anyway, so with that, I'm going to go ahead and stop the recording.